Nobody in the Kremlin saw it coming. Not the generals who designed the Shahed campaign as an attrition weapon, filling Ukrainian skies with hundreds of cheap Iranian-derived drones every night, and watching Kiev exhaust its Patriot interceptor inventory at 40 times the cost of every drone it shot down. Not the logisticians who calculated how many months it would take before Western resupply rates fell behind Ukrainian expenditure rates, and the equation resolved itself in Russia's favor through pure arithmetic. Not the strategic planners who had built the entire drone campaign around one foundational assumption that the defender always pays more than the attacker in this specific type of warfare, that the asymmetry of cost is a weapon as powerful as any warhead, and that the mathematics of depletion were inexorable and patient and certain. The assumption was correct. The mathematics were real. The trap was genuine, and Ukraine solved it with a drone that costs $1,000. In March 2026, Ukrainian interceptor drones destroyed 33,000 Russian air targets in a single month. Not 3,300, 33,000? In February, the number was 16,500. A 100% increase in a single month, achieved not through a dramatic influx of Western military hardware or a new alliance commitment or a diplomatic breakthrough that changed the fundamental resource equation. Achieved through an engineering insight so elegant and so operationally devastating that the Russian General Staff is still processing what it means for every assumption that the Shahed campaign was built around. The insight is this: if Russia attacks Ukraine with cheap drones, the solution is not expensive missiles. The solution is cheaper drones. This sounds obvious stated plainly. It was not obvious to implement because the interceptor drone is not simply a smaller, cheaper version of an air defense system. It is a fundamentally different category of weapon that operates on principles that traditional air defense doctrine does not account for. It is a drone designed to hunt other drones, to find them in the dark using thermal cameras that detect the heat signature of an engine that cannot hide its warmth, to close with them at speeds that exceed what the target can evade, to destroy them with a 500-gram warhead that costs 1,000 times less than the Patriot missile that would otherwise be required to produce the same result. 1,000 times less. Let that ratio settle into its full operational meaning. Every Shahed that Russia fired at Ukraine cost approximately $20,000 to $50,000 depending on the variant. Every Patriot interceptor that Ukraine used to shoot it down cost approximately $3 to $4 million. Russia was not primarily trying to destroy targets with the Shaheds. It was trying to destroy Patriot missiles. Every successful Ukrainian air defense was a successful Russian economic attack on the Ukrainian defense budget and the Western stockpiles feeding it. The Shahed was a missile-killing machine disguised as a drone strike campaign. Ukraine changed the equation by refusing to fight on Russia's terms. The Sting drone, developed by Wild Hornets under the Brave One Defense Innovation Cluster, is the primary instrument of this revolution, and it requires specific technical examination because the specific details reveal why it works when more conventional solutions failed. The Sting is 3D printed, not manufactured in a traditional defense industrial facility with the supply chain complexity and production bottleneck constraints that conventional military hardware requires. Printed on printers that can be distributed, replicated, scaled, and operated in facilities that do not present the kind of concentrated production target that a Russian cruise missile or ballistic missile strike can eliminate in a single hit. The aerodynamic bullet-shaped body is designed for one purpose: speed. The Sting reaches 340 kilometers per hour. A standard Shahed travels at approximately 180 to 200 kilometers per hour. The intercept geometry works because the Sting is substantially faster than the thing it is hunting, giving its AI-assisted guidance system time to compute corrections and still close the gap. The thermal camera developed by Kerbis and Odd Systems is the sensor that makes night operations possible. Heat is the Shahed's unavoidable signature. The engine produces it. The exhaust disperses it. The thermal camera finds it in the dead of night, at ranges that allow the engagement to begin well before the Shahed reaches its target. The 500-gram warhead at the end of the approach either detonates near the target or the Sting collides directly. Either way, the Shahed breaks apart in midair and the debris falls over open terrain rather than into the civilian areas the Shahed was targeting. The cost of this outcome is between $1,000 and $2,500, against a Shahed that costs $20,000 to $50,000 to produce and deliver to Ukrainian airspace. The Sting does not replace the Patriot. The Patriot handles ballistic missiles and cruise missiles, the threats that fly higher, faster, and with warheads large enough that a near miss is not a solution. The Sting handles the low-cost drone threat that was designed specifically to deplete Patriot inventory. Each system operates in its own domain. Together they form a layered air defense architecture, where the expensive system is reserved for the threats that require it, and the cheap system addresses the threats that were specifically designed to drain the expensive system. This is not just engineering. This is strategic doctrine. The P-1 Sun from Skyfall represents the system's extreme lower bound in cost and the upper bound in resistance to Russian countermeasures. At approximately $1,000 per unit, fully 3D printed and modular, it is the cheapest air defense system currently operating in any war on Earth. The fiber optic control architecture is the feature that makes it uniquely immune to the electronic warfare toolkit that Russia has been deploying throughout the conflict. Fiber optic control means the command signal travels through a physical cable rather than through radio frequency transmission. Radio frequency signals can be jammed. Fiber optic cables cannot be jammed. The P1 Sun operator's commands reach the drone regardless of what Russia's electronic warfare systems are doing to the electromagnetic environment around the engagement. In the first months of 2026, P1 Sun interceptors shot down over 3,000 Shahed drones. A version launched from an AN-28 aircraft has entered testing, introducing the flying mothership concept that extends the interceptor's operational range and repositioning flexibility beyond what ground-based launch can achieve. The Bullet model adds the top end of the interceptor spectrum with a jet-powered hybrid design capable of 600 km per hour, fast enough to intercept Russia's new jet-powered Shahed variants that were specifically developed to outrun the earlier interceptor generations. Ukraine developed a faster interceptor before Russia finished scaling its faster drone. This is the adaptation pace differential that the Russian General Staff cannot close through centralized industrial management and Soviet-era bureaucratic structures. Ukraine's Brave 1 Defense Innovation Cluster is not a defense ministry. It is an ecosystem. More than 280 companies developing more than 550 active solutions. Every month, new companies join. Every month, new models are tested. Every month, existing models are refined against the specific lessons learned from the previous month's engagements. The production output of this ecosystem is not a single weapon system being manufactured at a single facility against a fixed production plan. It is a continuously evolving portfolio of solutions being manufactured through distributed, redundant, scalable channels that Russia cannot eliminate with any single strike package. Over 10,000 Sting drones are produced every single month. Russia's response to the interceptor program has been exactly what the strategic logic of an institution trying to counter a cheap asymmetric system produces. Every response is more expensive than the thing it is responding to. Russia is developing jet-powered Shahed variants. The Bullet interceptor already handles them at 600 km per hour. Russia is deploying foam plastic decoys, the Gerber and Parity systems, in 30% of its attack waves. Decoy drones designed to deplete cheap interceptors against targets that are not real. Ukraine's AI-powered thermal cameras distinguish real targets from decoys through the heat signature differential. The number of interceptors wasted on decoys is decreasing as the AI systems accumulate more training data from actual engagements. Russia is spending more to be less effective. Ukraine is spending less to be more effective. The cost asymmetry that Russia built the Shahed campaign to exploit has been inverted. Not partially, not in specific engagement scenarios, systematically, at scale, in the production and logistics and doctrine and adaptation dimensions simultaneously. The operational record from individual units makes the aggregate statistics human rather than abstract. Roman Hulk, the pilot with the call sign from the Bulava unmanned aerial vehicle unit, destroyed 2 Shaheds with a Sting interceptor from a distance of 500 kilometers on April 4th. A world record at the time, the first occasion in history that an interceptor drone operator had engaged and destroyed a target at such a distance from their starting position. At the moment of the engagement, Hulk was in a safe position hundreds of kilometers behind the front lines. No physical danger? No exposure to the threat environment that would previously have required an operator to be within line of sight range of the target. The Bulava unit has been active since November and has neutralized approximately 200 targets with a 95% success rate, including the jet-powered Shahed variant capable of 600 km per hour. The 500-kilometer record stood for 13 days. On April 17th, Wild Hornets raised the bar by a factor of 4. A Sting interceptor, controlled by a pilot located outside Ukraine, at a distance of 2,000 kilometers from the engagement, successfully operated in northern Ukrainian airspace. The pilot sat in an apartment somewhere in Europe, watched a Shahed crossing Ukrainian skies on a high-definition video feed, and directed the interceptor to shred the target in midair from 2,000 kilometers away. 2,000 kilometers. The operational boundary between the interceptor operator and the interceptor's engagement zone has expanded to a radius that encompasses most of continental Europe. Operators who are physically safe from every Russian weapon system that can reach Ukraine are providing real-time combat air defense for Ukrainian cities. The Hornet Vision control system that makes this possible provides HD-quality video transmission with low latency control that overcomes the signal limitations that previously made remote operation at these distances technically impossible. The scalability implications of 2,000-kilometer remote operation are the detail that changes the entire strategic calculus of the program. Previously, one operator was required to cover 20 to 30 kilometers of airspace. With the current architecture, a single crew can monitor and protect hundreds of kilometers of territory. The personnel requirement for comprehensive Ukrainian air defense coverage has dropped by an order of magnitude, while the coverage area has expanded by an order of magnitude simultaneously. More sky protected, fewer people in danger, less logistics burden on the front line. The Foxtrot crew attached to the 38th Air Defense Regiment demonstrated what this scalability looks like in a single operational shift. In 24 hours, one crew shot down 30 Russian drones, 28 Shaheds and 2 Gerberas, using Sting interceptors. Wild Hornets has announced that such results have become routine, not exceptional. Routine, March 2026 numbers tell the strategic story at the institutional level. When Defense Minister Fedorov announced the figures on April 8th, the operational transformation they represented was visible in every dimension simultaneously. Over 33,000 enemy aerial vehicles destroyed by interceptor drones in a single month. Double the February figure. The highest monthly total since the program began. The vast majority were Shahed kamikaze drones. The remainder were reconnaissance drones, the Orlan, Zala, and Gerber systems that Russia uses for targeting and artillery correction. Destroying reconnaissance drones does not just remove the drone from the sky. It blinds the artillery that the drone was directing. This is the cascading operational effect that makes the interceptor program more strategically significant than its primary metric of drones destroyed suggests. When interceptors shoot down Russian reconnaissance drones, Russian artillery loses the targeting data required for accurate fire. When artillery cannot fire accurately, Ukrainian positions sustain less damage. When Ukrainian positions sustain less damage, Ukrainian infantry casualties fall. And when Ukrainian infantry casualties fall, while the 1-5 casualty ratio is being maintained through coordinated drone and interceptor operations, the Russian attrition strategy that the entire Shahed campaign was designed to support starts running in reverse. March 2026 Russian casualties, 35,351, the highest monthly figure of the entire war, 96% caused by drone attacks. This is the operational feedback loop that the interceptor program has enabled. Ukraine is not just defending more efficiently, Ukraine is attacking more effectively because the air domain that the interceptors have cleared allows Ukrainian attack drones to operate against Russian positions with the targeting data and the survivability that a contested air domain previously denied them. Commander-in-Chief Syrskyi has confirmed that Ukraine holds a 1.3 to 1 advantage in the use of attack drones. Some brigades are targeting 30% robotic operations to replace infantry exposure. Zelensky has demanded production of at least 50,000 ground robots per year. The interceptor program is the air component of a comprehensive drone warfare transformation that is replacing the attrition logic of industrial-age warfare with the precision logic of autonomous systems. Ukraine is not fighting the war Russia designed to win. It is fighting a different war in the same geography. The historical parallel that this transformation most closely resembles is not a recent precedent. It is 1986 Afghanistan, and the parallel is precise enough to deserve the full analytical treatment. In 1986, the Soviet military was conducting its Afghanistan campaign with a foundational assumption about air superiority. The Mi-24 Hind helicopter and the Su-25 attack aircraft were the instruments of that superiority, providing close air support for Soviet ground operations and making the Mujahideen's ground-based resistance tactically exposed whenever Soviet aviation was present. The assumption was that the Mujahideen had no answer to rotary and fixed-wing aviation, that the air domain belonged to the Soviet military, that the cost of challenging Soviet air power was prohibitively high for any guerrilla force operating without state-level air defense systems. Then the CIA supplied the Stinger. The Stinger is a shoulder-fired man-portable air defense missile. It cost $20,000 to $30,000. The aircraft it began shooting down cost millions. Approximately 270 Soviet aircraft were destroyed by Stingers over the course of the program. The specific number is less important than the behavioral change it produced. Soviet pilots, who had been operating at low altitude to provide effective close air support, began climbing to altitudes where the Stinger could not reach them. Low altitude operation became survival risk. The close air support mission that the Hind had been providing to Soviet ground forces became tactically compromised by the altitude requirements that Stinger avoidance imposed. Supply lines lost air cover, ground operations lost close air support. Morale among Soviet aviation crews deteriorated as the psychological reality of operating in airspace, where a $30,000 missile could destroy a $1 million aircraft, shifted the risk calculation for every sortie. The Stingers did not win the war alone, but they shattered the myth of Soviet air power invincibility in the Afghan theater and were, by multiple historical assessments, one of the critical factors that accelerated Gorbachev's decision to withdraw in 1988 and 1989. Ukraine's interceptor program is the Stinger moment of the drone war, scaled by a factor that makes the comparison almost inadequate. Stingers were shoulder-fired with a range of a few kilometers. Ukrainian interceptors are remotely controlled from 2,000 kilometers. Stingers were available in limited quantities through CIA supply chains. Ukraine produces 10,000 interceptors per month. Stingers were effective against helicopters and low-flying aircraft. Interceptors can engage air targets of any type at altitudes up to 7 kilometers. Stingers were operated by fighters who were physically present in the threat environment. Ukrainian interceptor operators sit in apartments 2,000 kilometers from the engagement zone. Every dimension of the comparison shows the Ukrainian system at a multiple of the Stinger's capability and scale and safety profile, and every dimension of the Soviet response to the Stinger maps onto the Russian response to Ukrainian interceptors with the same inadequacy. Faster drone variants, countered by the bullet interceptor. Electronic warfare, irrelevant against fiber optic control. Decoys, defeated by AI thermal camera discrimination. Higher production rates, constrained by sanctions, skilled worker shortages at 4.8 million deficit, and Soviet-era bureaucratic innovation pace. Russian Z propagandist Mikhail Rebarzinchuk admitted it publicly. He said that blaming neighbors is a convenient excuse and that Russians must accept that Ukraine can now launch drones from very long distances. When a regime's own propaganda network produces admissions of this specificity, the gap between the official narrative and the operational reality has become too large to maintain even in the information environment that the propaganda is supposed to control. The international dimension of Ukraine's interceptor program is the development that transforms it from a national military innovation into a global strategic asset. Because the drone threat that Ukraine's interceptors were developed to address in the specific context of Russian Shahed attacks is not a threat that exists only in the Russo-Ukrainian theater. It exists in every operational environment where cheap one-way attack drones have become accessible to state and non-state actors with the resources to acquire them. The Middle East is the most immediate example. Saudi Arabia and the UAE have both begun showing serious interest in Ukrainian interceptors. The specific operational relevance is direct. Gulf countries are facing exactly the Iranian drone threat that Ukraine's interceptor program was engineered to address. The Shahed drones that Russia has been firing at Ukrainian cities are the same category of system that the IRGC has been directing at UAE territory, at the Fujairah oil terminal, at Gulf partner infrastructure throughout the current conflict. The AI-powered thermal camera that finds a Shahed over Ukraine finds the same heat signature over the Arabian Gulf. The $1,000 to $2,500 cost advantage that makes mass Ukrainian deployment economically sustainable makes mass Gulf deployment equally sustainable against the same drone threat. Ukrainian experts are providing on-site support for air defense against Iranian drone attacks in Gulf countries. This is drone diplomacy at its most operationally direct. Ukraine is not exporting a weapons catalog. It is exporting tested, combat-proven, continuously improved expertise built from 2 years of engagement against the specific threat system that the Gulf is now facing. No defense contractor's sales pitch can compete with a system that destroyed 33,000 enemy aerial vehicles in a single month and whose operational performance is documented in real-time engagement footage from a live combat theater. Poland's Prime Minister Tusk announced that Ukraine's drone expertise will be combined with Polish and EU funds to create an interceptor fleet for European air defense. Norway signed a joint drone production agreement alongside its $7 billion defense aid commitment, with thousands of medium-range drones to be produced in Norway with deliveries beginning this summer. Estonia signed procurement agreements and is allocating 0.25% of GDP to support Ukrainian programs. 6 defense industry agreements have been signed with Azerbaijan. Ukraine's Brave One cluster is becoming the R&D backbone of European and Middle Eastern air defense against the drone threat that is now the defining characteristic of modern warfare. Zelensky announced that spending priorities within the EU's €90 billion support package will be directed toward drones. This is not a procurement decision. It is the formal recognition by the European Union's defense planning architecture that the drone domain is where the decisive military technological competition of the coming decade will be fought. And Ukraine, not any NATO member, not any EU defense contractor, not the American defense industrial base, is the acknowledged leader in that competition. The timeline of the program makes its achievement more remarkable rather than less when examined in its compressed sequence. Spring 2024, first research and development work began through Brave One. 2025, testing and scaling phase. Early 2026, full operational capability achieved. March 2026, 33,000 targets destroyed in a single month. Concept to industrial scale in less than 2 years? In a country that has been under continuous warfare for over 4 years, with a defense industrial base that has been rebuilding under active air attack, against a Russian adversary that has been specifically trying to destroy the production infrastructure. For comparison, the procurement timeline for a new fighter aircraft in a major Western defense establishment runs to decades. The F-35 program began in 2001. The interceptor drone program that is destroying 33,000 targets per month went from concept to operational capability in less than 2 years, manufactured by 280 companies through a distributed production network that Russia's strike packages cannot eliminate because there is no single point of failure to strike. Russia's centralized defense industrial model produces the opposite dynamic. Skilled worker shortage at $4.8 million. Soviet-era bureaucracy that processes innovation at the speed of committee approval rather than the speed of operational necessity. Sanctions constraining the component supply chains that electronic guidance systems and propulsion technology require. Every Russian countermeasure to the Ukrainian interceptor is more expensive to develop, slower to field, and more constrained in production scale than the Ukrainian system it is trying to counter. Russia set up the cost asymmetry trap. Ukraine flipped it. The strategic consequence that flows from this reversal extends beyond the Ukrainian battlefield into the global military technology competition, because the lesson that 33,000 destroyed air targets in a single month teaches is a lesson that every military planning staff on Earth is reading, and that every adversary with a drone-based coercive strategy is now having to account for in its operational assumptions. The Shahed as a strategic weapon relied on the asymmetry between its cost and the cost of the systems defending against it. That asymmetry was the source of its strategic value. Remove the asymmetry, and the Shahed becomes what it physically always was, a slow, thermally visible, electronically trackable, algorithmically predictable flying object worth approximately $30,000 that can be destroyed by a 3D printed drone worth $1,000. Iran builds Shaheds. Iran uses Shaheds against UAE targets. Iran has been using Shaheds against Gulf partner infrastructure throughout the current conflict. The Gulf countries are discovering that the Ukrainian interceptor program offers the specific technical solution to the specific threat they are facing, tested under the exact combat conditions that a sales brochure cannot replicate and that no other vendor can match. Ukraine is selling combat-proven drone-killing technology to the countries that Iran has been attacking with the Iranian-derived drones that Ukraine's technology was developed to destroy. This is the strategic irony that the global spread of Ukrainian drone expertise produces. The IRGC's Shahed strategy created the operational environment that forced Ukraine to develop the interceptor. The interceptor's development created an export product that is now being acquired by the countries the IRGC is attacking with the same drone. Ukraine's battlefield necessity has produced the Gulf's air defense solution against Iran's primary remaining offensive weapon system. Every Shahed that the IRGC fires at UAE infrastructure is a data point that demonstrates to Saudi and Emirati defense planners exactly why the Ukrainian interceptor is the system they need. And every interceptor that Ukrainian experts help deploy in Gulf countries is a degradation of the operational effectiveness of the IRGC's drone threat that the IRGC's own actions created the market demand for. The future of war belongs to autonomous systems. Defense Minister Fedorov said this, and the March 2026 numbers provide the empirical foundation for the claim rather than leaving it as strategic vision. 33,000 autonomous engagements in a single month. A 95% success rate in documented unit-level operations, a 1-5 casualty ratio in the ground war that the air superiority these autonomous systems provide enables, a production rate that is doubling quarterly through the distributed manufacturing ecosystem that makes suppression of the production base operationally impossible. This is what a military technological revolution looks like from the inside while it is happening, not the dramatic, single-event transformation of a nuclear weapon test or an aircraft carrier's first deployment. The gradual accumulation of operational results that each individually seem incremental and that together constitute a fundamental change in the logic of military competition. Russia's biggest problem is not the number of interceptors in Ukrainian inventory today. It is the adaptation pace differential that makes that inventory larger and more capable next month than it is today, and larger and more capable in 3 months than next month, while Russia's response options are constrained by the sanctions and the worker shortages and the bureaucratic innovation pace that cannot match the rate at which Ukraine's Brave One ecosystem is iterating. The Soviets had a saying about the Afghan stingers after the withdrawal. They acknowledged that the weapon changed the war. They never fully acknowledged how fundamentally it changed their operational assumptions until the evidence was already irreversible. The Russian General Staff has a similar acknowledgement problem. The Z propagandist admitted that Ukraine can launch from very long distances. The operational reports documenting 35,000 casualties in a single month are in the system. The intelligence assessments of what 33,000 air targets destroyed in March represents for the viability of the Shahed campaign's attrition logic are being processed. But processing an operational reality and changing the strategic assumptions that the entire campaign was built around are different problems. The assumptions are embedded in the doctrine and the production planning and the force structure and the strategic communications architecture that the Russian military establishment has committed to for years of this conflict. The interceptor drone has not just changed the battlefield, it has changed the question. Russia asked, "How long until Ukraine runs out of missiles?" Ukraine answered, "We don't need missiles anymore." And every night that another Shahed falls from Ukrainian skies, shredded by a $1,000 3D printed drone controlled from an apartment 2,000 kilometers away, the question that Russia asked at the beginning of this campaign gets a little harder to ask again. Because the answer that Ukraine produced is now being manufactured at 10,000 units per month. And the ecosystem producing it grows by new companies, new models, and new capabilities every month. And the countries that are buying it are the countries that are being attacked by the weapon system it was designed to destroy. The attrition trap that Russia set has closed around the institution that set it, and the stinger moment that changed Afghanistan is echoing across the drone-filled skies of a war that is teaching the world's militaries what the next century of conflict looks like. Ukraine is writing that lesson in real time, at $1,000 per page.